Welcome to our channel. In today's tutorial, we'll be diving deep into the intriguing world of side-channel attacks. We'll learn what they are, how they work, and most importantly, what we can do to mitigate them. Let's get started. First, we'll define what a side-channel attack is. Unlike typical attacks that exploit system vulnerabilities, side-channel attacks exploit information leakage from the physical implementation of a system. This includes examining things like timing information, power consumption, electromagnetic leaks, or even sound. To illustrate this concept, let's consider a simple example: timing attacks. An attacker might measure how long it takes for a system to process certain inputs. Differences in processing time can reveal whether bits are being processed as zeros or ones, thus leaking sensitive information. Here's a basic example in Java that demonstrates how timing can leak information. We'll create a method that compares two strings and takes longer to return if they differ, thus revealing information based on the timing of our response. In this code, the method will take longer if the strings differ, thus potentially allowing an attacker to infer information about the input. It's crucial to always mitigate timing side-channel attacks when dealing with sensitive data. Next, let's explore power analysis attacks. These typically involve measuring the power consumption of a device while it processes cryptographic operations. By analyzing these patterns, attackers can potentially recover secret keys. In practice, power analysis might exploit different types of cryptographic operations by observing power levels. To provide a more tangible example, let's discuss the concept of differential power analysis, DPA. In DPA, an attacker collects power traces during operations and statistically analyzes them. Let's consider a simple representation of how DPA could be conceptually implemented in Java. This is a simplified example to depict the idea rather than an actual implementation. In a real-world scenario, the power usage data would be collected and statistically analyzed, allowing the attacker to deduce the secret key by correlating power consumption with certain operations. Now that we've gained some insight into how side-channel attacks function, let's examine some strategies to mitigate these vulnerabilities. First, implement consistent timing mechanisms. It's essential to ensure that every operation takes a uniform amount of time, regardless of the input values. In this example, we ensure that the comparison takes a uniform amount of time, avoiding any timing leakage. The secure equals method performs comparisons in a constant time fashion, regardless of differences in string content. Next, let's look at how to deal with power analysis attacks. One effective strategy is to implement a technique called blinding. Blinding involves introducing random noise into cryptographic computations to obscure power consumption patterns. In this example, the addition of a random value alters the resultant output and makes it difficult for attackers to correlate power consumption with specific operations. Using blinding techniques helps obfuscate the relationship between input data and the resultant power usage. Another important mitigation technique is to use constant power algorithms. Designing algorithms that have a constant power profile is vital. Although this can be significantly more complex, it makes it much more challenging for attackers to conduct power analysis. In this constant power operation method, we add dummy operations to ensure that the power characteristics remain consistent. This approach complicates the attacker's task of inferring valuable information from power data. Furthermore, hardware-level mitigations should also be considered. Some processors provide features that assist in reducing side-channel leaks, such as power analysis shielding or noise generation. In addition to these methods, it's vital to keep your software infrastructure up to date and implement security practices like code audits and threat modeling. Regularly reviewing and updating your code can help catch potential vulnerabilities early. To summarize our discussion today, we explored side-channel attacks, including timing and power analysis attacks, and discussed various mitigations, such as constant time operations and blinding techniques. It's crucial to always stay informed about new techniques and potential vulnerabilities. Thank you for joining me in this comprehensive exploration of side-channel attacks and their mitigations. If you found this video insightful, consider giving us a thumbs up and subscribing for more programming tutorials. Don't hesitate to leave comments or questions down below. See you next time.